Okay, good day class. So this is for the Android DC motor. As you can see, I already created the circuit. So let me run through all of it. First and foremost, remember what we're using here is an um, double throw, single pole double throw. Sorry for that. Single pole. That's meaning one double pole. Should I say double pole double throw? Meaning you have two common, so this is your common, okay, and then two poles, so these are your poles. Poles in the sense of in relay, it's all about the magnets. Once the relay is magnetized, for example, this is your common. This is the normally closed. In a relay, there is a normally closed and normally open. So as you can see here, this one is the common. So once the relay is energized, it's shifted, so creating a magnetic flux or magnet, should I say. And then it creates now a switch from one connection. So that's why it's called double pole. So because this is um, a double pole, double throw, we have two commons. Why we need to have two commons? Because what we want is using one motor, we could either have counterclockwise or clockwise. So if I start, as you can see, if checking your activity, once button one, so this is our button one, this is our button two, okay? If we press button one, then it shifts or clockwise. So if you check on the motor, it moves in a rotation of a clockwise. If we release, then it stops. And then if we press the other button, it will now do the counterclockwise. Okay, so let's build into our circuitry. First is checking on this. So we have two relay. Okay, so this is the first relay. This is for the counterclockwise. Second relay, this is now for clockwise. So initially, here on terminal 16, we need to have positive. Okay. I put positive on terminal 16 because what I want, if I trigger low here, then it will automatically turn on your relay. Okay. The use of the diode is so that it will now go back to our and protection to our circuit or Arduino, should I say. So that's really it. Now let me discuss again. Common. So this is our common. So this common is for the negatives or the pin one of our terminal one of our motor. Remember, motors does not have positive and negative. It has black and red to declare that if this is in positive and that is negative, it will rotate clockwise. And if it's vice versa, then it will go counterclockwise. So as you can see here, terminal 1 connected to the first common or terminal 4 of our relay. So both relays have the same connection for our motor. Terminal 1 of our motor. For the terminal 2, as you can see here, now will now be on the terminal 13 of both relay. So what I just did is just to jumper on this to check. Okay. Now, if it is turned off, actually, if it's turned off, then automatically it is connected from the common terminal 4 and terminal 6 are connected. So once it is turned on, for example, if I press this, then the connection now here, look, check on this, guys. Check on this, okay? So once I press, it changes, okay? Because I press the button to turn on the relay. So if you check on this, right? Check on this, then it will move. Press, then it will move. So that's the beauty of the relay, meaning it's now connected to terminal 8 once the button is pressed. So the same thing with the other thing. So if I press, you check on this, then it changed figure, meaning common now is connected to terminal 8 of the relay. So that's what that means. So automatically, this common, once the relay is turned on, is connected to terminal 9, and terminal 4 is connected now to terminal 8. Else, if it's not turned on, terminal 4 and terminal 6 are connected. Okay? Do not mind this one. I put this because in simulation, it declares in our Tinkercad that the simulation will not push through. So I put value here in the common ground. I put value here on the normally closed, the first batch, first group of this relay, just in order to simulate. Okay, so do not mind this. But what I did here is to connect it into positive. So this should be red. Sorry for that. Connect it to positive so that once it turns on, positive connected here is also connected because this is automatically normally closed. So they are connected. So I make that as a positive. Okay, so let's run down to our connections. What I did here is as you can see, in relay CW, meaning clockwise. So if I trigger this, so this is on digital pin 13. So that's why it's in digital pin 13. Now in digital pin 12, that will now be relay counterclockwise. I put negative here, our diode, so that it is a protection. So if this is 1, it will not push through here because it's negative going through the diode only to create now the continuity needed to turn on the relay. Okay, so we are done with this. Here we have int button CW value and button counterclockwise value. This is to handle it will catch now the digital read from BTN-CW and BTN-CCW respectively. Continue to that. Now here, going back to the relay, remember terminal 16 is positive, terminal 1 now is going to our analog, and vice versa. For example, sir, can we create that what I want is to trigger the relay via 5 volts or high in our Arduino? That's possible, but you need to utilize pin 16. In this circuit, I utilize pin 1, so negative is the one to trigger the relay to create now, turn on the relay. Okay. Now for the bottom, I have 3 and 4. So 3 now, 4, as you can see, for button counterclockwise, and 4 for button counterclockwise. So 3 for clockwise, should I say. 4 now is button counterclockwise. Okay? Now on our void setup, just merely declaring which one are for output and for input, because remember in our digital input IOs, we could be either input or output. Declaring it, it's needed to know for our Arduino to know how they will be utilized. So serial begin 9600 baud for us to communicate with our Arduino, so we could utilize now our serial monitor. This of the serial monitor just for me to know or to see if the value going now to my values BTN-CW and BTN-CCW is either 1 or 0, so that I know what's happening. But first, in our bottom loop, BTN-CW or clockwise value will now catch the digital read of BTN-CW. That will be either 0 or 1 because that's a digital read, so that's 1 or 0 or high and low only. Then we have BTN-CCW as the value will catch now the digital read BTN counterclockwise. So once it's catch, what I did is I put now here the serial print. This is only to declare text. So if I turn on the monitor, so this is it. this serial print, okay, this serial print is this one only, okay. Remember, there's a space to declare the space. Then btn CW value, this one, okay. So that's the 0. Another one is print, serial print. I put space so that we have spacing here. We have space here. So without this, automatically 0 and BTN CW are connected, are together. And also put space here. Then I put serial print ln. As you can see here, it's ln rather than this. It's only serial print. The ln declares the new line. Okay, that's why every time after displaying BTN CCW value, it goes now to the next line because of the ln. Okay. Now this is the easiest part. If BTN counterclockwise value is equal now to 1, then it will give value on our relay W, this one, okay, 0. Remember, 0 is to trigger the relay. So once it is triggered, then it will move. So if we check it, so you can see in the BTN CW in serial monitor, it becomes 1. Once it becomes 1, the motor now is rotating. So you can see here, you can see now the RPM. Remember, this is only simulation, though the RPM is 9,994 RPM. So that depends now on the battery and the source of your Arduino. Remember, if we're pertaining now to motors, Arduino's power is not sufficient for so long. Because the more components you connect to your Arduino, of course, you're going to divide it with the capability of the Arduino. So for now, because we're only using one, then that's okay. If I press this one, so else, meaning if I am not pressing this, it's now become 0, then the value is now high. We need to declare high so that it will not rotate. So that's now for the BTN clockwise, and then we're going now for the BTN counterclockwise value. So if it is 1 now, then we're going to have a digital write relay CCW low. So if I press this one, it becomes now low, and then it will now become, the rotation of the motor now is counterclockwise. Okay. Else, of course, you can release this, and then it becomes now relay as high, meaning it will not turn on. So this is the basics how you need to satisfy the activity in our Arduino pertaining to the DC motor using now a relay to interface with it. So if you have any more other questions, do not hesitate to contact me in all platforms that it is being prescribed to you guys. So this is our activity, and thank you for listening. Bye guys.